Okay, so this is just a quick little video on how to make an animation inside of Desmos, the online graphic calculator. So these two functions, crazy things right here, you see, these we're going to be using. They both have these little exclamation points, too many variables, that's going to be okay for now. But basically what these two functions are is this big thing up here are the giant square root. All of this is going to allow us to actually make the animation when we eventually add a slider for D and C. Or I guess we can technically do that now. But we're not actually going to have them like move or anything. We're not going to have that just yet. But our second function here, all these little, they look like zeros with a line through them. Those are thetas. All of those thetas are going to be eventually replaced with a number, which is going to be basically our angle. And, well, actually, first thing we need to do is find a good example where we can just find literally any function. So instead of going super complicated or anything, we're just going to start off with simple sine of x. We have just our normal wave of sine x. Pretty simple. So basically what we do with this function is we kind of take the fact that we can say y equals, there we go, y equals sine of x, or f of x equals sine of x. They're the exact same thing. And apply that to this portion of the equation. So basically what we do is, in this case, is we can copy and paste this whole half. It's the exact it's going to be the exact same, but this second half, it's going to be interesting because basically what we do is sine of everything that's in here, which we can also just copy and paste over. And then, like before, equals 0. Now, we can choose an angle. We can even choose the angle being 0, which is basically saying that there's no change in the angle, so it should be the same as this. Yeah. Since they're 0, all these numbers are 0, it's basically saying that there's no change in like rotation. So if I change each of the zeros to a 10, you can already see one of them changed, but I have to change all of them to a 10 to make it accurate. Actually, I can explain it like this. It's like usually the axis, the sine graph follows along this axis right about here, but since we change all those thetas to 10s, there's a change in 10 degree, which actually now that I'm looking at it, it's kind of weird. I think it's something like that. It's not fully accurate because I'm not a master in this kind of stuff, but that's kind of just the point, the idea of it. But the thing about this is that to make this graph animated, all we do is copy and paste that big thing up there, and our big equation down here, this red line, all we got to do is multiply all of that by that giant thing. We can also now get rid of this one. Now, even though all of this huge thing says it's just this one little line, that is actually because there's a very, very small sliver in difference between the D and C sliders. A slider, it means because you can just change the value of them no matter what you do. The interesting thing about this is that if you get them both running, actually, hold on. An interesting thing about this is that you have to change to the animation mode to this second one, repeat in one direction, so that when it hits the end, it goes back to the other side. So you can kind of see as they move, the difference between the C and D sliders is just very small. And because of that, see that line moving? That's a very small line. If I tried to make the difference a little bigger, there you go. That line that's snaking up and down, it becomes a little bigger. If there's a huge difference in the D, if the D slider is a lot bigger than the C slider, then a lot of that graph is going to show up. But if the C is generally ahead of the D slider in this case, it looks like, well, yeah, it just kind of shows up for a half second, then disappears. Isn't that kind of cool? All of that. Also, we can get rid of this one, which we can just leave with that. That's pretty cool.